All right, guys, we are finally back from our break. We managed to pry away from his observatory, Greg Marshall, who was introduced to me by Wayne. And Greg showed me a couple of interesting things recently from his observatory. And I thought, you know what, this guy needs to be on one of our live chats, because the experience and the knowledge that this guy has is just second to none. And I thought it would be beneficial for you guys to hear this from somebody who is a programmer, engineer, who does a lot of that kind of stuff, but is also an astronomer, which is the important part. So, Greg, give the introduction about yourself.
Hi. So I have been an electronics engineer for most of my life, and most of that was involved in computer graphics and imaging. My last real job was with Xerox, designing controllers for printers and copiers and such. But for the last 10 years, I've just been doing stuff all related to astrophotography. I was involved in what I now call terrestrial photography for most of my life. Tried to be a fine art photographer, and it finally dawned on me that I'm just not that artistic. So I turned to something where I can make better use of my technical skills in astrophotography. And that quickly led to needing things that weren't available on the market, or where there were things that are available, I wasn't happy with them. So I designed my own. And that eventually led to meeting Wayne and the rest of the folks at Feather Touch, and we've been working together since then to bring some of these products to market.
So Wayne, tell us, how did you meet Greg and the relationship here?
When I want a customer for life, so Greg was actually a customer of ours. Biggest thing I want to know, whether through a phone call, some emails, what do they do? What's their story? Family, kids, work. What do they do? Everybody has their own unique story. So when I got to know a little bit about Greg, we started throwing some ideas back and forth. We met. He flew out from the West Coast to NEF, and we sat down, had some talks, and he's one of our does some software for us, or does some work behind the scenes for us. So not only was he a customer, now he's I don't say an employee, but does some background work for us. So getting to know people. If I didn't realize what he did, not knowing the relationship, we would never met this way. But it's worked out very, very well for us.
Excellent. Now, Greg, you have an observatory, which you have this fantastic name for the observatory. So give us a bit of information about that real fast.
Yeah, well, I guess probably a lot of people have a little backyard observatory with a roll-off roof. That's what I did. I actually moved where I am now about 10 years ago. And it's just a suburb of Portland, Oregon. So the skies are not very dark, but it's the important thing about this neighborhood is that there's no trees around. We have an open field behind us, so I've got lots of sky coverage. So I built an observatory there, and the door to it is only about 5 feet high. And when I first started using it, every time I went in, it knocked my head on the damn thing, which maybe explains a few things about me. So I decided I needed to put a sign there to remind myself. And if I was going to have a sign there anyway, it might as well be the name of the observatory. So it's Wa-Chur-Ed Observatory, or Wa-Chur-Ed Observatory.
Excellent. Stephen Ramsden is on the live chat. He says, hello, Wayne.
Steve, it's always a pleasure. Sorry I missed you at NEF this year.
That's because NEF didn't even happen this year. Go figure, right? Okay, so let's get into the meat and potatoes of this talk. So we are going to be talking about cable management specifically. This has always been one of these nightmares that I think a lot of people choose not to address. They kind of just tie everything together and just let it dangle off the back and hope for the best. So you run an observatory, of course, and this is what I've noticed. Is I've gone in and out of countless observatories. I've seen these great big roll-off ones in New Mexico, and the most common thing that I've seen is this massive cabling. And it's crazy because I've always watched these people when they do their setups, that they balance their scopes and do all of this and then connect all the cabling on, not realizing that the cabling itself creates weight and can also unbalance the scope. So this is basically your time here to go through this, to try and address some of these myths. And for those of you who are watching at home, please send in your questions. We will try to answer them as we go through. If I know he's going to answer the question at a later point, I won't do the question, otherwise we'll end up repeating ourselves to death. But don't hesitate to send the questions in. So just get ready with them and then we'll go from there. So Greg, take it away.
Okay, so yeah, your point is exactly right. I can't tell you how many people I've seen, not only beginners, but people who have been doing it for some time. I have a friend who has invested a lot of money and is very serious about astrophotography, but still hasn't managed to get to those cables. And you made the point about the cables having weight to them, more weight than you might imagine. But it's actually worse than that because it's not static weight. It changes as you're tracking across the sky. You're dragging these cables with you. So the amount of pressure and the direction of that pressure on your equipment changes. So well, there are a number of bad things about this, but it certainly makes it difficult to get good tracking and guiding, especially with a mount that is marginally able to handle your load. Adding that extra dynamic weight to it and drag is a problem. Perhaps more importantly than that is, of course, the possibility of cables catching on things, cable snag, we call it, and possibly doing some serious damage. So the traditional thinking on cable management, of course, you start with being neat. Get your cables bundled together with some caveats on that, of course. You have to be careful of signal integrity in some cases, but for the most part, make it neat. Then what you want to do is to minimize the amount that things are moving. So you make enough loop in the cable to handle all the movement, and then fix it right at the point where you have rotation in the mount. This is assuming that you don't have a mount that supports through the mount cabling. So you can make two loops, one to handle the declination axis and the second to handle the right ascension axis. So you need enough cable length in each of those loops to allow free motion all around. Having these points as close as possible to the point where it rotates minimizes the amount of change in the weight. So you're doing the best that you can to make this work, to track and guide properly and avoid cable snags. I don't have any pictures to demonstrate this, but they're really easy to find. I did it the other day. Just Google telescope cable management, and you can see any number of pictures of good and bad examples of this. So I use a Paramount Mighty mount, which does support through the mount cabling. And so I, a long time ago, started using that. And I thought that this was very good. Certainly it avoided all the mess and all the possibility of cable snags. And by definition gets you that concept of everything going through as close as possible. This is as close as you can get through the mount, is right there at the point where things are rotating. But I found I had a whole lot of cables in there. I could actually feel it. And in particular, the Paramounts have a very nice feature of on the back of the Versa plate, there's a little electronics box that gives you USB power and some other things. And that's all supported through cables that run through the mount. Well, I wasn't actually using any of those things that they provide because the USB, there's only 2 ports and they're USB 2. The power is very limited. So I essentially made my own version of that stuff. And then after running the cabling through the mount, I removed all the stuff that Paramount had put in it because it's a lot of cables. And I was surprised actually that after removing those cables, I could feel the difference, that the mount turned more easily. Oh. So this was sort of the beginning of a concept that we have the technology today to allow us to really minimize the amount of connections up, going from the ground or from the floor of your observatory up to the telescope. USB 3 with 5 gigabit transfer rates provides all the bandwidth that you need to support everything that you do. You combine that with a single power cord, and you can have a whole system with just 2 cables. So we talked about this, myself and Wayne and John at Feather Touch, and decided to do something about it. So we came up with this. This is called the Power Hub. So it does the things that I just described. Right here is a 12-volt power input, and then you have numerous power outputs, both front and back. USB 3 upstream connection to your computer, and there's an internal hub with 6 USB 3 outputs. Now, this does most of what you need, but there's still some things that you need at the telescope, specifically focus control, like we talked about with Wayne earlier, and dew heaters. So we integrated those things into this box also. You have here 3 dew heater channels. Actually support both bipolar and unipolar motors. Not simultaneously. It's not a dual channel focus controller, at least not yet. But you can use either one. Then right here, there is, the third area is a connector for an environmental sensor so that you can get temperature and humidity data. The Feather Touch motors provide temperature information already, and that's available through that connector. But it doesn't give you humidity, so we added an additional connector. It's unfortunate that it would be nice if you could just put that sensor inside the box, but then it wouldn't be giving you the ambient temperature and humidity. It would be telling you what's inside the box, which being an electronic device is going to be a little bit warmer. So there's a number of interesting things about this, perhaps starting with this connector right here. If you can see it, this is an Anderson power pole, something that is gaining a lot of popularity in astronomy. It's already extremely popular in the field of ham radio, which has a lot of overlap. A lot of people in ham radio are also into astronomy. They're great connectors. They're inexpensive, very easy to construct the connectors yourself. They're, what is the right word for it? I want to say unisex. Genderless is the right word, I guess. So you put together a black and a red pair, and another black and red pair just mates with it, even though they're exactly the same as each other.
Sorry, Greg, I'm just going to hold you for a second. Hey, sure. Wayne, can you mute your microphone, because I can hear whoever's on the phone in the background having a good old conversation.
I have kids at home.
All right, thank you. So we decided to use that most definitely for the power input, because this has to handle all of the power for your entire system. whatever gear you might have is going to be powered through this one cable. So similarly, we also provide a nice hefty cable. This is the standard cable, and you can get a better look at the power pole connectors there. This is 14 gauge wire, and we will have the option for heavier cables also, and different lengths if you need something longer than the standard 2-meter cable. Also has one power pole output. If you've got say a real big camera that needs a lot of power, plug it in here. This will handle up to 15 amps, which is massive. I can't imagine anybody actually needing that much, but there it is. The others connectors are all your standard barrel connector, the 5.5 by 2.1 millimeter, because that's what almost all equipment out there today is. However, we chose these connectors very carefully. These are just awesome connectors that I don't think I could possibly get it close enough so that you could see it. But the outer contact here has multiple fingers that really grab onto the outer barrel of the connector really well. So I'm impressed with how well they work. You could have used the threaded connectors that you often find on some astronomy gear, but unfortunately that doesn't help if you don't have the right mating connector. Whereas with this thing, you can use essentially any 5.5 by 2.1 millimeter barrel connector. It'll mate with this and it'll make excellent contact. So let's see. I have a demonstration of the accompanying software app, but maybe I should pause here and see if there's some questions before we jump into that.
Let me just make sure Wayne is unmuted now. So just unmute your microphone, Wayne.
Okay, I'm good now.
Okay, great. So there are a couple of questions that came right off the bat, other than Steve Ramsden saying he'll see you next year, assuming it happens. I'm going to go for the obvious one first. How does this compare with other devices? The guy was pointing out something specifically. I'll answer that part in just one second, but how does this compare to all the other products out there? Because I believe that there are 2 or 3 different companies out there now with similar products. So what did you do different in the approach?
Yeah, well, first of all, we should divide them into 2 categories, those that have processors and those that don't. So for example, and the ones with processors actually are pretty wide range too, anything from the ASI Air up to the new BISC Sky Fusion product, which has a very powerful processor in it and correspondingly high price. And then there are a number of products more similar to this. We decided not to put a processor in it for a couple of reasons, but what it really comes down to is this. The processor that you use for your astrophotography it needs to be flexible. Things change all the time in the software world. We have new versions of software all the time. And when new software comes out, it's always going to be first for the Windows market. If you build a processor into a box like this, you have a choice. You can either make it an inexpensive, low power kind of processor, which can work for a lot of people. And a lot of people are very happy with systems like that. But you're limiting yourself. Someday you're going to want to do something that either the processor doesn't have enough power to do, or the software is just not available for that platform. So I personally believe that using a laptop computer, it's a commodity. They're very powerful and inexpensive. if we tried to replicate that to put inside a box like this, there's no way that we could do it as cost effectively as the computer market does. They make them by the millions. So we decided not to go that route. All right, so comparing it with other boxes that don't have processors in them, basically, this is pretty similar to many of them. I just tried to make it better in every way that I could. Let's start with the power pole connectors. These are great connectors for high current applications like this. Frankly, you need a good power cable. If you're going to feed everything through a single cable, it has to be able to carry that current, not just from a safety perspective, but you don't want to have too much voltage drop. The more current you're drawing from it, the more the resistance in that wire matters. You get voltage drop, and then you're not really getting 12 volts to the system. So we made the system capable of carrying lots of current. It actually will support up to 30 amps, although I can't really imagine anybody ever needing that much. The standard cable is 14 gauge, much heavier than I've seen from any other similar products. And we can provide you with heavier than that if you want, up to 10 gauge, which is very substantial. So all the internal circuitry is designed to handle that. It uses heavier than normal copper planes in the circuit board to help both with the current and with heat dissipation. The focus controller, of course, is a big part of it. That was what we did first with Feather Touch and the EFS product. So this has essentially the same controller built into it, plus the support for unipolar motors. Some of the competitive products, I think Wayne mentioned one that nominally supports the Feather Touch motors, but not really very well. Yeah, and I think Wayne was talking about there's just too much power. Well, I can be a little bit more precise with that. With the bipolar motors, they're actually 5-volt motors, and you have to control the current. I mean, you have a 12-volt supply. So they uses pulse width modulation to limit the current going to that motor. So the controller that Wayne was talking about doesn't do that. It's providing full 12 volts to that motor, which will burn it out eventually.
Right. So one of the things that you probably haven't mentioned, and to me this is a critical part in terms of this particular product, is this is actually made here in the US. This is not stuff that is sourced from another country, imported, dragged over, or whatever the case may be. It's made here in the US. And Jeff from Optech is a prime example of somebody who champions this type of mentality, is having a product that is designed in the US, made in the US, manufactured and whatever, and it's made by an astronomer for an astronomer. That's the critical part to all of this. So a lot of time and effort has actually gone into thinking about how this particular box comes together. A lot of people are asking, what is this box called? Because obviously people are going to want to buy it at some point. Do you want to do that part now, or should we do that later towards the end? I don't know if you want to do it now, Wayne.
Oh, I'll let Greg take care of that. But what you just said, Simon, was very key. When people purchase stuff, again, it doesn't even have to be in astronomy. If they have a problem, who do they call? Are they trying to get a hold of somebody overseas? Or are they trying to get a hold of a reputable company in the U.S.? Much easier dealing with a U.S. service agent, whether it be language or time frame issue. It's just the quality is so much better long term.
Right, exactly. And I think that's one of the biggest things that really puts a dent in people here in the US specifically. I know there's a lot of people around the world that watch this, and obviously you guys will have the opposite problem to what we have. But for the people watching here, the products that I usually buy, I want to know that the manufacturer is behind it and supports it every step of the way, and I can talk to somebody. And to be totally honest, even if you called Wayne, as long as they're within office hours, doesn't matter where in the world you are, he will answer. So it's not like, you know, they hide and pretend that nothing happened. So yeah, let's go into how do people find this particular power hub, because obviously a lot of people are interested in it right now.
Yeah, well, we're still in the pre-release stage with this. I showed you this box, and I did not point out that this is a prototype. I don't really know for sure if it's going to look like this in the end or not. You know, the position of these connectors will, because that's defined by the printed circuit board. But the box itself is still a little bit up in the air. Similarly, the software that I'm going to show you is essentially done, but you know, it's not released yet. So we're just consider this prototype stuff.
A target release date is hopefully going to be sometime in early October if everything comes together. Once Greg finishes his part up, we'll send it out to multiple other beta testers because everybody's going to use their system somewhat differently. So once that feedback comes back, probably late September, maybe early October at that point, we should be ready to go. So maybe as late as November 1, we should have everything completed, tested, and ready to sell.
Yeah. So Wayne, I could ask you: Are we definitely going with the name Power Hub?
As far as I know right now, yes. So it'll be called the Power Hub.
So this is going to be a typical Starlight Instruments named product. It's exactly right. What it is. It's a Power Hub.
That's correct.
We don't spend time on hiring marketing agents and firms to come up with our names. We just think inside the box, not outside the box on that.
Literally. What I'll do is, for those of you who are watching on the live stream and you are here in the US, if you are interested in becoming beta testers, please contact Wayne, because at the end of the day, we're not creating a product to try and sell and make tons of money. We're trying to create a product to help you, the people out there as astronomers. Greg didn't make this to try and make money. Greg made this possible because he has a problem that he's trying to solve. And instead of just doing it for yourself, why not share it out with everybody else? So if you're interested in participating in this beta testing, and I'm just going to let you know, it is a bit of a closed system, so you do have to ask to be a part of it. You know, we just don't just randomly send stuff and just never ask for it back. You will have to return this, so you don't get to keep it. You know, be aware, you are a tester. But I do ask any of you guys who are in the US watching the stream, if you want to become a beta tester, please get in touch with Wayne, and we'll see what we can facilitate through that.
Yeah. And I should clarify here that there has already been a fair amount of testing. I don't call it alpha testing or whatever, but I've had a number of people had this for almost 2 months now, as we were continuing to develop it. And I'm very grateful to those testers. They found one very large bug and numerous little things that have all been cleaned up now.
Just to answer Ben's question real fast, it says, how does it compare to the Eagle, or is it an alternative product? It is not the same as the Eagle. The Eagle is a different situation. The best way for me to describe the Eagle is if you are going to do a set up and tear down remote system and you're trying to keep everything self-contained, that's what this is for. That's what the Eagle is for. Not to say you can't use this particular product in the same fashion. You still have to have a cable that runs back to you because it's not completely Wi-Fi. So that's the essential difference. There's a computer inside of an Eagle, obviously, because that's what it's about, whereas this is an actual power box. Right. Oh, that's a good question. How does it, if I wanted to attach this to a telescope, how does it attach to the mount, the scope, or whatever? I don't think we covered that part.
Yeah, and that's, as I mentioned, this prototype here, actually, this one doesn't have it, but there are some little tabs that come off from the ends of this with quarter 20 holes in them. In this one, this is my own unit. I drilled and tapped a hole right in the center so that I do this right to a plate on the top of the telescope. But that is stuff that is still up in the air, unless there's stuff that Wayne hasn't told me about yet.
No, that's one of the finer points we have to do the research on. Different types of setups, different how to attach it. So that's one of the last parts that we have to do yet, and that's where the feedback from other customers come from. Mounts are going to be different. How their setups going to be different. What's I don't say universal, but what a flexible way to mount it that services multiple people at one time.
Again, if you guys have suggestions, we're all ears. Again, this is something that we are designing for you guys to use at the end of the day. Stupid question, how much does it weigh?
That is a good question. I've never weighed it. It would hurt if you hit your head with it. It's all metal, of course, aluminum. I have no idea. If you like, I can go grab some scales and measure it.
Well, I mean, this is still the prototype product, so we probably don't want to get the weight of it just yet. Are you guys going to also treat the board as well? Because this thing sits outside, and the number one biggest problem is dew. I know an electronic device already creates enough heat on its own to try and keep the dew off, but what if I leave it out and it's not on and it dews up and I turn it back on? And water and electricity doesn't mix very well.
Right.
So are you guys planning on doing things like that, spraying the board, or have you already addressed that issue?
It's a great question, one that I was not expecting, but I do have an answer for.
Oh, good.
The way to do that is what's called conformal coating. In my career, I did some military electronic stuff, and that is the standard procedure there. But it's also extremely expensive to do. So I don't know of any electronic products out there that do that. Maybe some of the real high-end mounts do, not sure. But nothing that I've ever run across does it. It's possible we could do it as an option on this. I would certainly like to have it, but it's very expensive.
Yeah, the actual coating procedure can be expensive.
Yep.
All right, let's stop delaying. Let's have a look at the software.
Okay.
All right, so you want to start the screen share?
Yep. Let's bring it up here. Okay, so this is the application right here. So this is a standalone application for the Power Hub. There is also an ASCOM driver. And oops, I just killed it there. I'll bring up. I use Maxim DL most of the time. So I brought that up over on the right side. Usually hits full screen, but just so that we can see everything. All right, so I have already, there's a button right down here that we click to connect or disconnect right now. Well, I'll disconnect it so we can go through the process. I guess first it has to have focus. Why didn't that do anything? See, anytime you do a live demo, something's going to go wrong.
Yeah, it always is the case.
Okay, it is connected. Oh, I know why it wouldn't disconnect. Exactly. What I was about to say is that in order to use the ASCOM driver, you have to have this app running. And this is fairly common these days. It's just like with the Paramount mounts, you have to run the SkyX in order to control the mount, and then you go through that software with an ASCOM driver to control it through third-party apps. So that's the same situation here. I'm now connected to the focus controller through ASCOM in Maxim DL, but it goes through this app, and therefore it won't let me disconnect. In fact, it tells me right here, it says ASCOM driver is connected. Okay, so let me just disconnect that so that I can demonstrate this. All right, so normally when you launch the app, it would come up and look like this, and it says ASCOM is not connected, or it's disconnected. Click that. And now we get the green indicator that we're connected. I go to settings and set up Power Hub. This is where we set most of the features. We've got these name fields, which I can change for each of the power outputs. Currently, actually, I'm going to call it big load on output 1 because I have a huge power resistor on there. I'll use to just show you that it can handle a lot of current. And my second output, I have my ASI 1600. Okay. And then similarly with the USB ports, I can name them. So I have the ASI 1600 connected to port 6 and my Lodestar guide camera on port 5. Now there's one output of the Power Hub that can be used for several different purposes. It can be another standard output like all the other 12 volt outputs. And you can see that just showed up over there as just another switchable output. Or I can make it a PWM, that's pulse width modulation output, which you can use for a number of purposes, and I'll get around to that later. Or thirdly, I can make it into a third dew heater channel. I can see it showed up down there. So I'm going to set it for PWM in this case and name it flat panel. Okay, there's a number of other settings here. There's a couple of LEDs on the Power Hub, and we can control how bright they are. I usually have it set at 2/3, especially during the daytime. At night, I might go to 1/3. Now you notice that on each of these ports, there is an option for power on at startup. By default, all of the USB ports come up when you power the thing up. But the power ports, you can select whether they turn on automatically or not. And by default, they're off. Now you'll note that of the 6 USB ports, only 3 of them have this. Only 3 of the USB ports are switchable. The other ones are always on. Let's see, there are a number of other things on here, most of them not terribly important. Down at the bottom, we have automatic dew control. So this slider here lets you adjust a trigger point in temperature, but this is not the absolute temperature. It's the difference between the ambient temperature and the dew point. So right here it tells you that the dew point is 10.4 degrees, and so it's now set up with a 3-degree delta. So that means that the dew heaters would turn on at 13.5 degrees. Okay, so I'm done with all of that. Just close that. We have a number of tabs up here. The main one is the power tab. So I can just turn on and off all of these different outputs. We'll start first with my big load, which is just a big resistor. It's a 1 ohm, 200 watt resistor. We can see that our power has gone up to almost 140 watts. So our incoming voltage is 12.1, and that dropped a little bit because of the heavy load on it. There is some voltage drop in the cables, as I mentioned. So it's drawing 11.4 amps currently. And we can see that on a graph over here. I have to change the scale on this. It defaults to a 10 amp scale, but with that big a load, I have to go to the 20 amp scale. So this is showing the current in red and voltage in yellow. And the bottom graph is showing the environmental data, the temperature, humidity, and dew point.
Just out of curiosity, does this thing have a voltage regulator built into it?
For the 12 volts?
Yes.
No, it does not. That was actually one of the very first questions that came up from a tester. It's something that I seriously considered in the design, but the bottom line on it is it's expensive and not as useful as you might think. Here's what it comes down to. Any of your astronomy gear that really needs a tightly regulated voltage, like a camera, is going to take 12 volts in and regulate it down itself to what it needs, typically 5 volts or 3.3 volts or even lower. The things that do matter, what the voltage is, are things like dew heaters and thermoelectric coolers. The higher the voltage is, the stronger that effect. I'm not going to say more efficient, because that isn't technically true. But obviously, if you are running your dew heater at 13 volts, it's going to run hotter than it would at 11 volts. So it would be nice for those situations to have regulated outputs. But the truth is that if you've got 12 volts coming in, unregulated, and you want a regulated 12 volts output, that's hard to do, especially in that in-between area. If your input is exactly 12 and your output also wants to be 12, it doesn't know, am I trying to raise the voltage or lower the voltage? These are like two entirely different operations for a DC to DC converter. So it's possible, but it's expensive and problematic and not really that important a thing to have in most cases.
Other question here is do you plan on Indie compatibility, or should I really say, does this work on a Mac?
Yeah. This application is strictly for Windows. I'm not really that kind of software engineer. I did all the embedded software in this thing, but at the application level, I'm not an expert. I know that in many cases it is possible to easily port something like this from Windows to Mac, but I'm certainly not going to commit to that. I don't.
Just right. Okay.
Yeah,
because I think a lot of people who do this astrophotography stuff or astronomy in general, a large group of users are Mac users. I'd probably say about a good 20 to 30% is a Mac user.
Yep.
And then, of course, there's ASCOM Alpaca, which is be another thing. I mean, if this thing is already ASCOM compliant, getting this over to Alpaca is going to be dead easy.
Right. Yeah, that is probably the next step.
Well, I mean, this is the thing. I don't want to change the subject here because we've done this talk before, but I mean, if this is written in Alpaca, or if any of your devices at home are Alpaca, the platform is irrelevant, because Alpaca, that's the design of it. It doesn't care if you're on a Linux machine or a Raspberry Pi or a Mac or a PC or whatever. It will work across platforms. So again, the groundworks for creating something like this to work in Alpaca is already there. The only difference here is the end user is what adopts it, not us. We can't force you to do anything. Here's a good question. So would this be a solution if I wanted to control a unipolar motor on an OTA and a bipolar motor on another OTA the next time I want to use it? In other words, not side by side or at the same time, but if I have multiple setups is what he's referring to, I think.
Yes. In fact, Wayne was talking about that before with the focuser bus controller, the fact that simply having two channels means that you don't have to change the settings. So we actually handle that here fairly well also. Bring up the configuration menu for the focuser, and right down at the bottom is a motor selection. So it has three predefined ones, the two feather touch motors, the handy stepper motor and the PDMS. The third one is your standard 12-volt unipolar, such as RoboFocus, such. And the other 5 are user selectable. You can put your own name on this and change all the settings to whatever you want. And then when you switch from, so I'm sorry, one of those selections, I killed it. It's just there behind it. So right here is motor type. We can select bipolar or unipolar or no motor if you're not using it at all. So like Wayne was saying, it's in this case, it's not a true dual channel controller. So if you're using one at a time, yeah, it's very, very easy. And well, I don't know if we could say idiot proof, but it makes it very easy to switch from one to the other. While we're here, I can go back to Maxim DL, connect to it, and see that, look at that. He's got the number here, he's got the number there. And I can control it from either side. I can tell the standalone app to move out 100 steps. He does, and the number changed over here too. Here I'll move in 50 steps. Changes on both. They both show the same temperature.
Is there input power over voltage protection?
Yeah, there's all kinds of protections. Go to the status tab here. These are all the faults. On this page, these things are latched. So if anything happens even momentarily, you'll get a fault message. I can make that happen with a very simple fault. If I just unplug the environmental sensor, it'll take a little bit because it doesn't, yeah, there it goes now. So it's telling me that something's wrong with the environment sensor. And if I go over to fault actions here, I can say, well, yeah, I know there's something wrong. I unplugged it, so just ignore that. I still have to go back here and clear this fault. So yeah, you have input voltage over under tests, the total current, variable voltage, separate current measurement for each of the outputs, including the DO channels, the multi-purpose output. Like the environment sensor, there's also a fault if the motor temperature sensor fails. There's also a fault that comes from the driver chips for the focus motors. And lastly, there's an internal fault. If the system, it's always monitoring itself. If it finds something wrong, it triggers that fault. Now, most of these things actually have 2 different levels of fault. See over here, we can select what to do on each of these faults. And for the most part, this applies only to the first level faults. The first level is basically just a warning. It tells you something's not normal here, so pay attention to it. And you can program it to ignore those or to pop up a message when they happen, or if you like, you can even make it so that the first level fault either closes the port if it's specific to one of the outputs, or close everything to shut down the whole system if it's a global thing like over under voltage or excessive total current. When there's a second level fault, you don't have any option of it. It's going to turn off that port to protect itself and your equipment. So it watches these things constantly. Each of them is a little bit different as to how and how often it is checked. But for the most part, most of these things are tested internally 5 times per second. Except total current is actually 50 times per second, and so on.
So this is actually a feature that I haven't really seen much of being utilized by many people. that's actually quite a good thing to have, because then in an observatory setup, if say it goes, pear-shaped,
Yeah.
I could be notified, or I can have it set up to do an action, or just straight up just shut down.
Yeah. In fact, something that one of the testers pointed out to me, I hadn't really thought of, is that one of the reasons it's very handy to have the power switch on the USB ports is if you have some equipment fail, and especially if you're doing it remotely, you can't go over there and unplug it. But if I just turn it off here, it does the same thing. It's just like going over and unplugging the USB cable for that device. Then you turn it back on and it resets itself. Along the same lines, what you were bringing up, on the power page here, there is a total amp hour readout. This is a cumulative thing. It's telling you, and this is useful if you're running off from batteries, to tell you how much power you have used in this session. We can reset this at any time. So normally you want to do that at the start of a session, so you can see how much you've used.
Just before you keep going on, just to let everybody know, we've got about 10 more minutes left. If you guys got any more questions, try and cram them in now. Okay, so we've got about 10 more minutes left.
Yeah, I did want to demonstrate this PWM output. It can be used for a lot of different things, but what I use it for mainly is to drive a flat calibration panel. So you can see here, I can just control the brightness of that. It's got 1023 or 1024 different levels you can set the brightness to. On the dew heaters, similar operation, except that here it's just in percentage, from 0 to 100%. And it shows you the power usage. For these outputs, the display is in amps. But for dew heaters, what you really care about is how many watts it's putting out. So that's what it shows.
Watts is a measurement of heat, so you're trying to heat something up.
Yeah, exactly. I'll plug this environment sensor back in so we get numbers down there. Something I wanted to point out, I showed you the box here, and we have the standard RCA jacks for the dew heaters. These are actually terrible connectors. I'd like to find the person who first decided that this was the connector to use for dew heaters and just wring his neck or something, because they're just horrible. But we got like the best RCA jacks we could find there. I want to also point out that if you have a dew strap like this, it undoubtedly came with an RCA plug at the other end that is not even worthy of good audio equipment. This is a connector from a company called Pomona. I don't have the exact model number for it, but you can find it. Just Google Pomona RCA plugs. They make jacks also, but you want the plug. Get yourself some of these, cut off the crappy connectors that came with your dew heater straps, and put these on instead. They fit very nicely into the power hub. They just go right up against each other. They're just far enough apart that it fits. Do you have any questions?
Yeah, one of this is a comment. I'm going to do the comment one first. It would be nice if you put an Ethernet hub into it. 2 would be enough. Mini computers in and out external network.
Well, since there's no computer in this, there isn't anything for an Ethernet to go to. If you want to have a system with a processor mounted at the telescope, there are products like the Eagle that have that all integrated. And I told you why we decided not to go that route. But what you certainly can do is to get a headless computer like the Intel Do they pronounce it Nuck or Nuke? I never knew.
Nuck. It is pronounced Nuck, N-U-C.
Nuck. Okay.
Yeah, duck without the D.
Yeah. So get yourself a headless computer and mount it up there on the telescope. You have a short USB 3 cable from that to the power hub. And then you can use either Ethernet or Wi-Fi to go from that computer to your control and monitor system, be it a laptop or tablet, what have you.
So this is actually a really good question, and I was actually going to ask you this myself, actually. USB 3 ports, do they provide power? If so, how much? And how many amps?
Okay, so the switched ports provide up to 2 amps. The unswitched ones are standard USB 3 ports, which by the spec is 0.9 amps.
Perfect. All right, we're going to have to wrap this up because our time is almost up. I can run all day if I really wanted to, but I think we're going to run out of things to say at some point.
I could talk all day.
Yeah, well, maybe so could I. So who knows? So we've already talked about how when this is roughly going to be available, and I know that this is going to be the next obvious question. Do we have a price point yet?
We do not. Some of it's going to depend on if we have to change the design of the box for mounting. Some of that could drive up $25 to $50 fairly easy. So I don't want to back myself into a corner yet. But by mid-September, all those options should be pretty much ironed out with pricing.
Gotcha. And again, this is a product that's made here in the US. So for those guys who are in the US who are always looking for US products, this is a great way to support a business that's here. Of course, if you're anywhere outside of the US, this is still going to have full support and the whole 9 yards. It's not like we're just going to create something just to make money. It is made to help astronomers because it's made by an astronomer. And Greg, you're already using this inside of your observatory. So, you've thought about all these things and how you want to do the connections and stuff like that. One quick question before I forget. The power ports that you have, are they fused? And if they are, can the fuses be used or replaceable, or is this returned to manufacturer to get repaired?
They don't need to be fused because the current is constantly monitored. Well, actually, let me restate that. There's 2 levels of faults. There's 2 levels of handling of current. The first level is monitored by the internal processor. So when it gets over the nominal current for the given output, and each of the outputs has a different rating because of the type of connector used. So when it gets over that first level, the processor detects it. If you get to a really serious overcurrent situation, like a short circuit, the hardware itself will shut down the output.
Gotcha. But nothing else will turn off, just that port.
Right.
Right. So if you've got something that is pulling way too many amps, I'm trying to make this so these guys at home can understand it too. If you've got a device that pulls way too many amps, it'll shut down that port, but everything else will stay up. Is that correct?
Yeah. So conceptually, that's correct. In practice, I know because I've intentionally done this. In practice, what happens is if you actually short circuit one of the outputs, it will very briefly provide just gobs and gobs of current, and therefore the total current fault will be triggered, and it will shut down everything.
Right, gotcha. And the same thing can be said with the voltage, that you can't suddenly just slam into 14 volts. I mean, if you're powering off a battery, if you get 14 volts from somewhere, I'd be wondering what the hell you're doing.
Yeah, well, actually 14 volts is only a first level fault. It right. will handle 15 volts before it goes to a second level fault, and the circuitry is all designed to allow even quite a bit more than that. Beautiful.
All right, this just about wraps it up. Like I said, we could probably go on forever about some of these things and dealing with problems like cable management and stuff like that. First of all, Wayne, thank you very much for sitting through all of this. I've basically stolen 2 hours of your life that your wife can't have back. So I really do appreciate you taking the time out of your day to do this. And Greg, I really do appreciate you coming along and showing this product. Stay tuned for when the product announcement's going to come out. Hopefully we will have some of these units to start sending it out into the world for you guys to use. And again, if you're interested in doing beta testing for some of this stuff, or you have ideas, feel free to forward them over to Wayne. Again, the contact information is on their website, starlightinstruments.com, or you just Google it, you can find it. So yeah, any last words before we disappear?
Thank you, Simon, for the time. I had fun.
Yes, thank you, Simon, and it's good to meet you.
Yeah, likewise. Okay, so we will have information on our next live stream being published at some point. I believe I do have a date, which is going to be on September 12th. That particular one, or the theme, is going to be CCD versus CMOS. So be aware this is going to be a very, very heated debate. We are fully aware that there are a lot of pros and cons behind one thing versus another, but we're here to do a particular talk that we are going to stir some controversy, and I know there's going to be a lot of angry people on chat on this one, so this is going to be a lot of fun for us. But you know, we do need to keep it clean, so do keep cool. This is all fun at the end of the day. So once again, thank you very much for you guys for watching out there. Thank you to Chuck, who is long since gone because, like I said, his wife dragged him away. And of course, our two current guests right now, Wayne and Greg. All right, guys. So we will see you next time. If you haven't already subscribed to our channel, subscribe, click on the like button, do all your usual things, and I'll see you in the next one. Thank you very much.